So how do you characterise an unknown legacy nuclear facility when you don't know what hazards are inside? The first step is deploying drones on the outside. Drones can fly low, they can fly slow, and they crucially can fly close to buildings to record radiation data at different heights and different standoff distances. The radiation mapping payload on the drone contains a micro-gamma spectrometer, so not only can we measure the intensity of the radiation coming out from the building, but we can also separate it by energy to identify specific radioisotopes. By mapping all of the different faces of the building, we can get three-dimensional radiation data surrounding the entire structure, and from that we can then start to reconstruct where the strong radiation emitters might be inside the building. We do this by combining a three-dimensional model captured by scanning LiDAR with the three-dimensional radiation data and apply a Casimir algorithm in 3D to calculate where those emitters actually lie within the building. Now we know where those strong emitters are inside the building, it's sensible for us to then send the robots inside ahead of the humans.
So, we're here at the PCHP. Behind me is a heavily contaminated building, and inside we have our autonomous turtle rover with a radiation sensor moving to map radiation data in real time. I'm standing outside to reduce my dose intake and monitoring its progress in real time.
The rover maps its position inside a room by using a scanning LiDAR system, and it correlates this with the radiation intensity on an onboard gamma spectrometer it's carrying, and in doing so, as it moves around, it measures the radiation distribution. When we map the inside of a whole facility, we can create a dose distribution map which tells us where it's safe for humans to go, and it also tells us where we should go to take samples.
Once we've completed our fieldwork and mapped from the metre scale down to the centimetre scale, we can then take our forensic samples back to the University of Bristol. We then analyse them in a safe environment using a variety of forensic techniques, such as XRF, SEM and mass spectroscopy.
By applying these automated advanced techniques both in the field and the laboratory, we can accelerate the characterisation of nuclear facilities and thereby speed up nuclear decommissioning.